The topic for the lecture today is hypothetical judgment. And we will also reformulate the propositional logic using hypothetical judgment. First, we'd like to discuss why we need a new form of judgment called hypothetical judgment. So here's an example of a hypothetical proof. So let's consider the hypothetical proof of A implies B implies A implies B true. So in order to prove this, we apply implication introduction rule. So we introduce A true as hypothesis, and then we should prove B implies A implies B true. And then we apply implication introduction rule again to introduce B true, Y, and then, this is going to be A conjunction. And then we deduce A conjunction B true. And then we apply conjunction introduction rule. And this is a typical form of hypothetical proof. And the problem with this way of representing presenting hypothetical proof is it's your responsibility to keep track of the scope of every hypothesis. So for example, for this hypothesis, we can imagine that there is a contour like this one that specifies the scope of this hypothesis. And it's your responsibility to keep track of the scope of this hypothesis. For this hypothesis, the scope is restricted to the premise of this inference rule. So for example, you are not allowed to use this hypothesis outside this contour. So for example, you cannot use this hypothesis to deduce here. So this is not allowed. So there's nothing wrong with this hypothetical proof, but it's not quite convenient for writing the derivation tree, because you have to manually keep track of the scope of every hypothesis. So we introduce new form of judgment called hypothetical judgment. And its syntax is we enumerate a judgment, and then we use this turnstile symbol, and then we write another judgment J here. And this is called a hypothetical judgment, and it means that there is a hypothetical proof of this form. We eventually prove judgment J starting with hypothesis J1 through Jn. And in between here, we apply inference rules. So whenever there is a hypothetical proof of this form, we say that this hypothetical judgment is provable. And this symbol is called turnstile, and we say that this collection of judgment J1 through Jn entails the judgment on the right side, this judgment J. So this judgment is also called entailment relation. Entailment relation, say between this set of judgments called antecedents, in the sense that it appears before this turnstile, and this judgment, which is called the succedent, in the sense that it appears after this turnstile symbol. And some people call this relation consequence relation, in the sense that this judgment J is the consequence, logical consequence of this set of judgments. So this is the syntax for a new form of judgment called hypothetical judgment. And this hypothetical judgment becomes evident whenever we have a hypothetical proof of this form. The conclusion is going to be this judgment J, and we may use this judgment J1 through Jn as a hypothesis. So that's the syntax for hypothetical judgment. And in our study of proposition logic, we use only truth judgment. So we will be using this form of hypothetical judgment, A1 true, AN true, turnstile, C true. It turns out that we have already seen a particular form of hypothetical judgment before in the programming language course. The typing judgment of this form, expression E has a type C, where gamma is a collection of typing judgment of this form, x1a1 through xnan. This is actually a particular form of hypothetical judgment. This is a judgment which states that expression E has a type C, and this is a judgment which states that x1 has type A1. So essentially, there's no difference between this hypothetical judgment and the hypothetical judgment that we are looking at right now. It's just one particular example of hypothetical judgment. Okay, so we will be using this form of hypothetical judgment. Now, let's discuss the principles that should be valid for hypothetical judgment. So there are two principles that should be valid for hypothetical judgment. The first is reflexivity. The second is substitution. Reflexivity is stated as follows: gamma, judgment J, gamma prime, turnstile J, where these gamma symbols represent the collection of judgments or collection of hypotheses. And substitution principle states that if we have gamma turnstile J and gamma J prime, then we should be able to prove gamma turnstile J prime. This reflexivity principle shown over here states that you may use this hypothesis to deduce the same judgment. And this substitution principle states that basically in your system of logic, you may use lemma. When we are challenged with some complicated problem, we often introduce lemmas. We first prove this lemma, which is perhaps simpler than the final conclusion. And once we complete the proof of this lemma, we use this lemma in various parts of the subsequent proofs. And this substitution principle essentially states that you may use lemma. For example, here we prove judgment J. Now this is going to be a lemma. And in the following proof, to deduce J prime, we use this judgment J as a hypothesis which is okay because previously we have shown that judgment J can become shown to be true. We can prove this judgment J from the same collection of hypotheses gamma. So therefore, in the end, if you can complete the proof of J prime, you can deduce the same conclusion here. So this is the substitution principle, or you can call it lemma principle. And let's see why it makes sense to use this substitution principle. Why it makes sense to have this substitution principle in whenever we use this hypothetical judgment. Suppose that we have gamma entails J, and we also have a gamma entails J prime. According to the definition of this hypothetical judgment, it means that we have a hypothetical proof of J starting with hypothesis. It means that we have a hypothetical proof of this judgment J starting from hypothesis gamma. So let me write the gamma bar to indicate that these guys are all hypotheses. And let's just say this is hypothetical proof D. And similarly, according to the definition of hypothetical judgment, the proof of this hypothetical judgment means that we have a proof of judgment J prime, this J prime, starting with hypothesis gamma prime, and also a hypothesis of judgment J. This judgment J comes from here, and this is hypothesis. So let's say this is hypothetical proof E. So this is the assumptions. So we have this assumption and this assumption. And by expanding the definition of this hypothetical judgment, we produced these two hypothetical proofs. Now, I would like to make a copy of this hypothetical proof and replicate it over here. And what happens is we have J prime and we have a gamma bar, and instead of J, now we make a copy of this hypothetical proof, and then we have something like J gamma prime. So this is a copy of hypothetical proof B, and this is a copy of hypothetical proof E. Now we have a derivation tree that proves J prime, where we use hypothesis gamma and the same hypothesis gamma. But we learned previously that it's okay to use the same hypothesis once or twice or as many times as necessary, or even 0 times. So in the end, we can reduce this hypothetical proof into J prime, proof of J prime, starting from hypothesis gamma, because you may use this hypothesis 0 times, once, or many times. And this is precisely what completes the proof of this hypothetical judgment gamma J prime. So we have shown informally why this substitution should be a principle whenever we use this hypothetical judgment. Next, let's discuss structural properties. Structural properties of hypothetical judgment. Hypothetical judgment. Unlike these principles, so we have these two principles, reflexivity and substitution. These two these two are called principles because these two statements must hold whenever you use this hypothetical judgment. It's basically the price that you have to pay for using this hypothetical judgment. In contrast, these structured properties are just the assumptions that we use. So we make three assumptions. The first is called exchange. And formally, we can write it gamma ji plus 1, gamma prime entails j. If this is the case, then we may exchange the two hypotheses. Intuitively, it doesn't matter which one comes before and which one comes next. The ordering of these hypotheses doesn't matter. So we may switch these two, ji plus 1, ji gamma prime j. So this is the exchange property. The second one is weakening, which can be stated if we have gamma prime turnstile j. So we abuse notation here. We are a bit informal about the use of notation here. So gamma is collection of hypotheses, and gamma prime is another collection of hypotheses. And if these two sets of hypotheses entail this judgment j, then we may add another judgment j prime as a hypothesis to deduce the same judgment j. So in comparison with this hypothetical judgment, this new hypothetical judgment has a new hypothesis here, which is perhaps not used at all, because it suffices to have this gamma and gamma prime to complete the proof of J. And this property is called weakening, not strengthening, because essentially we weaken the power of the hypothetical judgment. If you compare this hypothetical judgment and this hypothetical judgment, this is stronger actually, and this is weaker, because both hypothetical judgments eventually deduce the same judgment, but this first one consumes fewer hypotheses. So in other words, this hypothetical judgment draws the same conclusion without consuming too much. By comparison, this second hypothetical judgment draws the same conclusion J, but with more hypotheses. So it is weaker than the first hypothetical judgment. So in this sense, this property or this assumption is called weakening. The third structural property is called contraction. Contraction is stated if we have gamma ji gamma prime entails j. So if this is the case, then we may contract these two into a single instance of ji. So if this is the case, then gamma ji gamma prime entails j. So we contract these two in order to leave just one instance here. So this property is called contraction. And if we think about these structural properties, this exchange means that the ordering of these hypotheses doesn't matter. So from this point on, we don't care about the order of these hypotheses. And if we think about the property weakening, it means that it's okay not to use a hypothesis. In this hypothetical judgment, we never use perhaps this hypothesis J prime, but still it's okay. So this weakening says it's okay to use a hypothesis 0 times, or that is, it's okay not to use a hypothesis. It's the weakening property. And contraction property means it's okay to use the same hypothesis twice. This contraction property says it's okay to use the same hypothesis twice. Because according to this property, contraction, you may always contract these two instances of the same judgment into one instance, because you are permitted to expand this judgment J into multiple instances whenever you want. So the implicit assumption here is that it's okay to use the same hypothesis twice. So these exchange, weakening, and contraction are called the structural properties because they deal with the structure of these hypothetical judgments. So far, we looked at the principles for hypothetical judgment. We started with the definition of a hypothetical judgment, and we looked at principles for hypothetical judgment. And keep in mind that these two guys are called principles, reflexivity and substitution, because these principles must hold for any logical system using hypothetical judgment. So there should be no exception. But as we will see later, whenever you develop a system of inference rules where we use hypothetical judgment, you have to first verify reflexivity and substitution. Because if these principles fail, it means that you make somehow wrong use of this hypothetical judgment. And we also looked at structural properties, which are assumptions. So these are not principles, these are assumptions. These are assumptions that we make when we use hypothetical judgment. So according to exchange property, we make this assumption. So the assumption here is, let's not care about the ordering of hypotheses here. And this weakening property is an assumption which allows us to ignore or not to use a hypothesis in the set of antecedents. And this contraction is also a property, structural property, or an assumption which allows us to use the same hypothesis multiple times, not just twice or multiple times. So these are structural properties that are specific to a particular system of inference rules using hypothetical judgment. So it's very important to be able to distinguish between these principles and these structural properties. For example, so you have some system here, system of inference rules. And we use hypothetical judgment here. Then, whatever the system here is, you have to show that reflexivity always holds and substitution principle always holds. But when it comes to structural properties, you may use different assumptions. You may make different assumptions. For example, in our study of logical system, propositional logic, in this course, we make 3 assumptions: exchange, weakening, and contraction. These are assumptions specific to our propositional logic. But in another logical system, we may choose, for example, allow exchange, we allow weakening, but we do not allow contraction. Contraction is not allowed. We can imagine a logical system here where reflexivity and substitution hold, but this contraction is not allowed. And we can consider another variant where exchange is permitted, but weakening and contraction are not permitted. This is not just an imaginary logical system, it's a very important branch in logic, which is called the linear logic. And we can even propose another logical system where this reflexivity and substitution hold, of course, but exchange is not permitted, and weakening is not permitted, and contraction is not permitted. And this is ordered linear logic. So what we needed to remember here is we will be using hypothetical judgment to formulate the system of logic. And the first job we have to do in order to ensure its sanity is we have to show the reflexivity and substitution. But when it comes to structural properties, we have to realize that they are just assumptions. So in our study of propositional logic using hypothetical judgment, we make these 3 assumptions: exchange, weakening, contraction. And of course, we will have to prove these properties separately. So far, we learned the notion of hypothetical judgment and the principles and structural properties. Now let's reformulate the natural deduction system for propositional logic using hypothetical judgment. So the goal now is we will be using hypothetical judgment of this form, okay, where gamma is collection of hypotheses of this form: A1 true, blah blah blah, AN true. And we'd like to use this form of hypothetical judgment to reformulate the propositional logic. And we assume that exchange is built in. So what I mean by exchange built in is we don't care about the ordering of these hypotheses in gamma. So the ordering of these hypotheses or these judgments doesn't matter. So first, we introduce this rule, hypothesis rule. Hypothesis rule. This hypothesis rule says whenever you have a true in the set of hypotheses, then you may use this hypothesis. So perhaps thanks to this hypothesis rule, this reflexivity principle automatically holds. For all the other inference rules, follow the same pattern. For logical connective, we have introduction rule and another elimination rule. So let me first formulate all these inference rules. Okay, what about introduction rule? Implication introduction rule. If you read this implication introduction rule, you end up introducing this implication. So the conclusion should look like A implies B true. And in order to prove A implies B, our intuition says you introduce A true as a hypothesis, and then you should prove B true. So therefore, the premise comes gamma A true entails B true, which states that in addition to all the hypotheses that you were given in the beginning, you introduce new hypothesis A true, and then you deduce B true. This is the implication introduction rule. What about implication elimination rule? Now we start with this hypothetical judgment. In order to use the fact that A implies B is true, you have to provide a separate proof of A true. And by combining these two judgments, you deduce gamma B true. This is implication elimination rule. What about conjunction introduction rule? So in order to introduce conjunction, you have to prove A true and B true separately. What about conjunction elimination rule? You have A conjunction B true, and then you can deduce A true by taking the left component. So this is the conjunction elimination left rule. And similarly, you will have a conjunction elimination right rule. What about disjunction introduction rule? This is the disjunction introduction rule. And there are two ways to prove A or A disjunction be true, either by proving A is true or by proving B is true. So in the case of the left, we prove A true. And symmetrically, we have A disjunction be true if B is true. And this is disjunction introduction right rule. So what about disjunction elimination rule? This time we start with a judgment of this form. And the goal is we'd like to eliminate this disjunction. So the idea behind this disjunction is whichever is the case, we always deduce the same conclusion. So we assume A true and then deduce C true. And we also assume B true and deduce C true. And then we can deduce C true, regardless of the A and B. Because we can always deduce the same judgment C true, whichever branch we take. For top, we only have this introduction rule. And bottom, we have only elimination rule. If you can prove a bottom true, you can prove anything else. So this is a bottom elimination rule. And you can also derive negation introduction rule. Negation A true if A true leads to bottom true. And you can also have negation elimination rule. So if you have negation A true, you try to prove A true, and by combining negation A and A, you generate the bottom. So this is basically the reformulation of proposition logic using hypothetical judgment. Notice that we never introduce label. That's the whole point behind using hypothetical judgment. We'd like to eliminate the need for annotating this hypothesis with label and keep track of its scope by drawing this imaginary contour. We instead use this hypothetical judgment. So there is no use of labels. In some sense, this hypothetical judgment automatically keep track of the scope of every hypothesis. So this is the reformulation of proposition logic using hypothetical judgment. So let's analyze this inference rule, implication introduction rule, to see why this is okay, why this inference rule makes sense according to the definition of this hypothetical judgment. Okay, so let's consider A implies B true, gamma A true, assume A true, and then deduce B true. This is implication introduction rule. The question now is, why is it that this inference rule in fact makes sense? We will show that this is actually derived inference rule from hypothetical proof of this form. Suppose that you want to prove A implies B true by applying implication introduction rule. So you introduce A true as new hypothesis. But suppose that in the beginning, you start with this set of hypotheses, gamma true. And then you have to prove B true. And you can translate the hypothetical proof in the premise into this hypothetical judgment according to the very definition of hypothetical judgment. So in other words, if you expand this hypothetical judgment according to the definition of hypothetical judgment, you expect something like gamma bar A true bar leading to B true, which is precisely the hypothetical proof shown over here. So the premise can be represented with this hypothetical judgment. Now, what about the whole hypothetical proof? This is a hypothetical proof because in the beginning, we start with A implies B true, gamma true as a hypothesis. So the challenge was to complete this hypothetical proof. So now we have the complete proof of this hypothetical judgment because this hypothetical proof directly corresponds to the meaning of this hypothetical judgment. In other words, if you expand this hypothetical judgment according to the definition, you are expected to produce a hypothetical proof of this form, which is precisely one shown over here. So what we are looking at here is this way of presenting hypothetical proof can be simplified with this inference rule using hypothetical judgment. And there's essentially no difference between these two. It's just manipulation. We just don't like the idea of having to annotate every hypothesis with a label, so we rely on new way of representing proofs, which is hypothetical judgment. But it's just the syntactic stuff. Syntactically, we use a different way of representing proofs, but essentially there's no difference between these two. So in this way, you can actually justify all these inference rules according to the definition of hypothetical judgment. Now, we have to go back to the structural properties and principles. So previously we learned that here, whenever you have a system of inference rules, you have to show that these two principles, reflexivity and substitution, always hold. And you may introduce a few assumptions about the structure of the hypothetical judgment. For example, we may choose to allow exchange, weakening, and contraction. But in another system, we may choose to allow exchange, but not weakening and contradiction. Sorry, not weakening and not contraction. But the system that we have just formulated, it belongs to this category. So of course, reflexivity and substitution must hold, but we made three assumptions: exchange, weakening, and contraction. So we have to now go back to the system and then show that all these assumptions are in fact valid, and this substitution principle and reflexivity principle indeed hold. So the story goes like this. You decided to use this hypothetical judgment, and then you make assumptions about the way that you use this hypothetical judgment. For example, exchange, weakening, and contraction. Now, according to the definition of this hypothetical judgment, and also the assumptions that you make, you formulate a system with many inference rules. So this is basically a set of inference rules. Now, you have to go back to this system after formulating this system. You have to revisit this system and show that indeed these assumptions are valid. Because it may be that you have introduced some mistake. There might be some mistake in formulating these inference rules. So you wanted to use exchange, or you wanted to use weakening, contraction, but maybe there is some bug in your system and weakening may not be the case, or contraction may not be a property. So you have to revisit this system and then show that these assumptions are indeed valid. And you also have to show that the principles, reflexivity and substitution, always hold. Because these two principles must hold whenever you use this hypothetical judgment. So the story so far, our story so far is, we decided to use this hypothetical judgment, we decided to introduce three assumptions, and then we formulated this system, propositional logic. But it may be that we made a mistake along the way in formulating this propositional logic. So in order to convince ourselves that we relied on these assumptions in the right way, in other words, we did not violate these assumptions, we have to revisit this system and show that these systems are okay. We have to actually prove these assumptions or structural properties. And of course, we have to show that these principles are in fact valid. So that's the remaining job. So we have now this system, and then the remaining job is, first, show the structural properties, and then we needed to show reflexivity and substitution. Let me just state that these are structural properties. So exchange is built in. We assume that the ordering of hypotheses in gamma doesn't matter. And weakening can be stated if gamma entails C true, then gamma A true entails C true. So when we complete the proof of this hypothetical judgment, we never used A true. So therefore, when you try to complete the proof of this judgment, it's okay not to use this hypothesis at all. So weakening says it's okay not to use. So this is the weakening property. And contraction can be stated as if you have gamma A true A true, C true, then you may contract these two, and you may have A gamma A true, integer C true. So it turns out that it is a contraction property states that you may use the same hypothesis many times. So now you have to actually formally prove these properties yourself, because it may be that you made the wrong use of the definition of hypothetical judgment. In order to show that that's not the case, it's your job, it's your responsibility to prove weakening and contraction. And the proof proceeds by induction, of course, induction on the structure of the proof of either this one here or this one. So we prove these structure properties, and the remaining job is to show that reflexivity is actually true and substitution principle holds. Reflexivity automatically holds because we have this hypothesis rule. Now what about substitution principle? If this substitution principle fails, the whole system is a nonsense, because it means that you cannot use a lemma. Okay, so the remaining task is to prove a substitution. So we state the substitution like this: if gamma entails A true and gamma A true entails C true, then gamma itself entails C true. So from the first condition, we show that A as a lemma, this is basically lemma that we introduce, and then we prove this lemma separately. And in the second part, when we try to prove C true, we use A true as a hypothesis, as if it was a given fact, which is okay because in the previous step, we showed that A is indeed true. But this is the question. And of course, the proof proceeds by structural induction, okay? Structural induction. And the question is, which of these two judgments should we apply this induction on? In other words, should we analyze the structure of the proof of this judgment, or should we analyze the structure of the proof of this judgment? The answer is, we have actually seen precisely the same problem in the programming language course when we tried to prove substitution lemma. So the substitution lemma in type theory states if gamma has, under typing context, the gamma expression E has type A, and we assume that variable X has a type A and E prime has a type C, then we deduce gamma under typing context, the gamma expression E is substituted for variable X inside expression E prime has the same type C. So previously we proved this substitution lemma or substitution theorem from the programming language course, and we are looking at precisely the same problem here. So the answer is, of course, we want to analyze the structure of this proof, this judgment. And later, when we learn Curry-Horde isomorphism, we will learn that these two statements are, in fact, completely equivalent. There's no difference. There's no difference in interpreting these two statements. They are stating precisely the same fact. Then the question is why we should analyze the structure of the proof of this hypothetical judgment. And the reason is intuitively we analyze the proof of this judgment, gamma A true, C true. Okay, and we also have this proof gamma entails A true. So the idea is that whenever we reach a leaf of this hypothetical proof, we have something like B true. And the idea is that we apply induction hypothesis to this hypothetical judgment in order to get rid of A. And we propagate the change all the way down to the root of this hypothetical proof, and then can get rid of A true. So that's the basic idea. So our intuition says that we have to analyze the proof of this hypothetical judgment and then apply induction hypothesis to every leaf found in this derivation tree, okay, in order to remove A true, and then propagate the changes all the way down to the root of this derivation tree. Then in the end, you can get rid of this A true. So that's the basic idea. So the answer is, of course, we have to analyze the structure of the proof of this judgment, or we have to apply structural induction on this hypothetical judgment. Just like in the proof of a substitution lemma here, we analyze the proof of this typing judgment.